So, where were we? We had just realized that, okay, we knew all the rules of how to analyze quantum code, and we were going to draw all the amplitudes on this diagram, and we were analyzing mystery toggles, this crazy thing, this toggles detective algorithm that can somehow determine all the contents of this mystery toggles subroutine, even though it only calls it once, and there's, any number of bits it's got to learn about. Now, we were doing the special case where there were only two possible toggles, x1 and x2, just because we wanted to keep it small. Well, that way we have 3 qubits. We can draw a 3-dimensional picture. If you have 4 qubits, you can try to draw a 4-dimensional picture, right, where you make a copy of this, another copy of this, in the 4th direction, goes from this side to that side. If there are 5 qubits, you're on your own. But luckily, we only have 3 here. Okay, so we were trying to remember how it worked, and we were doing one specific case, the case where mystery toggles, let's say, does toggle based on x1 and doesn't toggle based on x2. Actually, last time we checked that the case where it doesn't toggle based on anything, like this is empty, that case checked out. And now we're going to check this case, and then the other 2 cases you can check for yourself. And yeah, just to remember, so it's on the board, so we know what we're shooting for. In this specific case, the final output is supposed to be 1, 0, and then 1. Okay, so answer, this ans qubit is always output 1, but this 1, 0 is the main part. It's signifies that yes, 1, the first guy is in there, and the second toggle is not in there. So that's what we're hoping gets printed out at the end. And yeah, let's do it to check that it happens. As I said, you maybe won't really understand why it happens, but we just want to confirm that it does indeed happen. And then, that's what we're going to get into, the whys of what's going on here. Okay, so let's see. So let's just trace through this thing step by step. So we make these 3 qubits, and then we toggle the answer qubit. So at this point, after line 2, what is the state? After line 2, the state is just, 0, 0, 1. It's after line 2. And we decided it would be a good idea to plot all the amplitudes, or make a diagram with all the amplitudes, because there could potentially be 8 of them. So here's my fine diagram of all the 8 3-bit strings arranged on a cube, with each qubit corresponding to one of the 3 directions. And we, describe our states by putting the amplitudes here. So this really stands for 1 amplitude on 0, 0, 1, which is up here, and 0 everywhere else. Imagine I drew a red 0 in all the other 7 bubbles. I'm not going to do it because I'm going to change it in a second. I don't want to erase too much. Okay. So, good. Then last time we actually worked through these 3 steps as well. I'm going to fast forward that because anyway we're going to do these ones in detail. So allow me to fast forward this. So we did these 3 steps, the add in different steps, one in every direction. And let me just remind you what you get to. Yeah, you get to the situation where you have -1 amplitude on all the back face, and +1 on all the front face. Let's write 1, 1, 1, 1. Okay, you can go back and later remind yourself that that's what you get to after you do these instructions. And again, these instructions really are Hadamard-alls, and therefore, there's really these square root of halves, and so actually all of these numbers should be multiplied by square root 1/8 if you're doing it precisely, but we got over that. We were you know what, we're going to be chill and allow ourselves to multiply all the amplitudes by a constant to keep things nice. And that's why this actually represents an unnormalized state. The sum of the squares of the amplitudes is 8 rather than 1, but we know that we can just fix that up at the end when we need to. Okay, so let's say that's where we got to, and now I'll finish it. Any questions to getting up to this point? Okay. So I did actually do this step last time, but I'll do it again because let's be a little bit careful here. So, okay, so we call mystery toggles, and luckily for us, mystery toggles only has 1 instruction. It's this one. So if x1, then toggle ants. And as I said last time, it's kind of clear how this works. what happens, let's say here, you just go through all the basic states, and like you do the if x1, then toggle ants operation on it. x1 is the first one, ants is the third one. So for example, this one, 1, 1, 0 would change to 1, 1, 1. And this one, conversely, 1, 1, 1 would change to 1, 1, 0. So you could just like make that change and be like, all right, I'll erase this and write 1, 1, 1, and I'll erase this and write 1, 1, 0. But let's not quite do that, because that messes up your diagram. I mean, your diagram would still be correct, but it would be drawn in like now a confusing manner where like the vertex labels would no longer be corresponding to this picture. So instead of like, changing this to 1, 1, 1 and this to 1, 1, 0, like swapping these two labels, we'll just swap the amplitudes instead. That's the same thing, right? So that's what we'll do. So in fact, what we'll do is like swap this amplitude with that amplitude. So this becomes -1 and this becomes +1. And a similar thing happens here. This is labeled 1, 0, 0. So if I do if x1, then toggle ants, this would become 1, 0, 1, which is that. And conversely, 1, 0, 1 goes to 1, 0, 0. So instead of swapping these labels, we'll just swap these two amplitudes. So this becomes +1. This way becomes -1. And you see, in general, we're sort of swapping along these like in-out edges. But we don't do these swaps up here, because here's where x1 is 0. So like 0, 0, 0 just stays 0, 0, 0, because x1 is 0. And all the ones that start with 0, which are all the ones on the top face because of this, they don't change at all. So they just stay the same. Let me write plus, though, just for consistency. I have two different fonts for my numeral 1s. I don't know what to do about that. Okay, so I did this. I did the swapping. And so like this is the state after mystery toggles. Okay. Now had we not commented at this line, and like mystery toggles contain both these toggles, then we would have this if x2 then toggle ants. And I guess, how would that work? Only things would happen for the bit strings that have x2 being 1, which is everything on this right face. And then you'd still be toggling ants, which is like in and out direction. So I guess you'd be like toggling, you'd be like swapping like these in and out edges, but only on the right face. If you were to do that, which, we're not in this example. Okay. Let's do that. Let's do that. Okay. So now let's do the Hadamard stuff. And that would be good practice, because this is like the most interesting step where we do this like Hadamard or add indifference on all the directions. And here, what you'll basically see, what this does is it makes some cancellation happen. Right now we have like an equal amount of amplitude, at least in magnitude, there's some sign thing, but we have like an equal amount of magnitude on like all 8 possibilities. But somehow, these instructions are going to like start collapsing stuff, and it's been carefully designed so that it exactly, cancels in such a way that we get like all the amplitude on the correct answer and no amplitude on the wrong answer. And somehow this is a lot of the magic of quantum computation. You kind of like, compute something for every possible string, but then you cleverly arrange it so that they like cancel each other out, the pluses and minuses, and you get like all or most of the amplitude on the correct answer. So let's watch as that happens. And later in the class, we'll figure out like why it happened, or maybe in the next few lectures. Okay, so let's work on this, add and diff on ants. Now, how does that work? Again, ants is the varying part. The in-out direction is the varying part. x1 and x2 are the unchanging parts. So you kind of like pair up all the 3-bit strings according to the first 2 bits being the same. So like these two are a pair because it starts with 0, 0 and starts with 0, 0 here, and we have like just 0 and 1. So you kind of like just squint and imagine the only 2 things in your world is +1 amplitude here on 0 and -1 amplitude here on 1. And then you do the add and difference rule. And what is the add and difference rule? Well, the sum goes on to the 0 part, which is here, and the difference goes on to the 1 part, which is here. So we have to replace this with the sum of these 2 things, which is 0. And we have to replace this one with the difference, which is 1 minus -1, which is 2. Okay? Please watch me, because I may get the signs wrong, and I don't want to. We have to do that for all the edges. So again, like it's going to be like these in-out edges, because we're add and diffing on the ants direction. Like here, the unchanging part is 1, 0. The changing part is this last one. So we're got this edge. We put the sum over here. Sum is going to be 0. And the difference is -1 minus +1, which is -2. So this is 0. This is -2. And I guess probably all the sums are going to be 0. So let's do that. All the sums are going to be 0. And the difference is, well, okay, this was +1 minus -1. That's 2. And I think this one would be like -1. You have to remember, sorry, minus +1, which is like -2. What I should have done is like written them like in green, like the new values in green, and then like copied all the greens into the reds, but oh well. Okay, so we did that step. Any question? Okay, this is kind of fun. I wish I could go on for more, but we only have 2 left, sadly. Okay, so we're doing add and diff on x2. This x2 is like the horizontal direction. So again, let's just look at it. I mean, we're going to be pairing up all the edges into the sort of 4 horizontal edges, and we're doing add and difference on them. Okay, so the ones that are like 0, 0, they're just going to stay 0, 0. And then, okay, the other horizontal ones, the add of these two is 4, and the difference is 0. So this is going to become 4, 0. So let's do it. 4, 0. Okay, and the add of these two is -4, and the difference is 0. So this will be -4, difference is 0. And got it. Okay, last one, x1. So we're doing the up and down direction now. We pair up all the bit strings into the up and down direction, the x1 varying direction. Most of them are 0, 0 already, so 0 plus 0 is 0, 0 minus 0 is 0. Let's see. What's going on? Oh, x1, yeah. So we put the add here. So 4 plus 4 minus 4 is 0. And we put the difference. This is 4 minus -4, which is 8. That goes on to the one side, so this becomes 8. Okay, and actually you see, like, the phenomenon I promised happened. Like, a ton of cancellation magically occurred. And all the amplitude now is just on one basic state, 1, 0, 1. God, I hope it's the right one. Oh, it is. Good. Yeah, so like the state, well, the unnormalized state at this point, you know, is like 8 amplitude on 1, 0, 1, and no amplitude on all the other ones, so I won't write it. And then finally, we're like, oh, extract all time. You know, now's maybe the time where we should like fix up the state to a normalized state, so we know what the printing probabilities are. It's pretty easy here. It's just obvious that you should divide all the amplitudes by 8, and then you get, you know, amplitude 1 on 1, 0, 1, and amplitude 0 on anything else, and therefore you print 1, 0, 1 with probability the square of 1, which is 100%. And so, indeed, ta-da, like it revealed the exact contents of mystery toggles. Okay. Good. So I really wanted to go through that because, like, that's, you know, the mechanics of how, you know, you analyze code with quantum instructions and keep track of all the amplitudes and, like, see this phenomenon of cancellation happening. Of course, you're probably right to feel like, I have no idea what just happened. Like, we did a long calculation, and yes, like, the miracle occurred. And, like, he promised me that if I did the other 2 cases, like, the same miracles would occur. But why? How does one come up with this, or why does this work? Okay, that's what we're going to try to explain in the next couple of weeks, like why and how, the why and how of this, and similar things.